Today's video is on the product rule, but before we do that, quick review on monomials. A monomial could be a number, it could be a variable, or it could be a number with a variable. A few examples include a constant like 5, or -3, or 1/2. The variable could be x, it could be xy, it could be a number with a variable like 2x or 5x squared, just as long as it doesn't have addition or subtraction sign in it. It is a monomial. And monomials that have the same variables and exponents, they're called like terms. And we know how to combine like terms. We've practiced that a little bit in class. Let's do just one example together here, just to refresh our memory on how to combine like terms. But let's do an example where we have variables with exponents. Let's look at number 12 right here. Here we have 10m squared n plus 7mn squared minus m squared n. The like terms must have the same letters and the same exponents. You can only in this problem combine 10m squared n with the negative m squared n. Even though the 7 has an m and an n next to it, because it doesn't have the same exponents with the letters, with the variables, you cannot combine it with the other terms. 10m squared n's minus m squared n makes 9, and you leave the variables the same with the same exponents. Then, since your other monomial only had 1 right here, you're going to leave it as the 7mn squared. Again, number 11 here, you only can combine letters that have the same exponent. 13w squared and a 4w squared you can combine to make 7w squareds. And the other one is 9w's with a minus 31w's, which is a negative 22w's. Simplest form, you should always write the w, or in this case w, or the variable with the highest exponent, write that first, and then your normal variable, and then if you have a constant, write that at the end here. So variable with the highest exponent comes first, and then so on. That is simplest form. To multiplying monomials using the product rule. The product rule states that if we have two bases are the kind of like the bigger number attached to the exponent. If two bases that are the same and they're being multiplied, here you see the multiplication, and they're being multiplied, what we do with the exponents is we add them. So we leave the base the same. Notice how the base stays just as x, but we're going to add these two exponents, the a plus the b. Let's show you how it works in a couple examples. 17, we have x squared and x cubed. What we do is keep the base, which is x, the same, add the two exponents to get x to the 5th. A more visual way of how this works, I'll write that over here. X squared looks like x times x. Then we have x cubed, which looks like x times x times x. So all together, we have 1, 2, 3, 4, 5 x's, which could be written as x to the 5th power. Number 18, we have a to the 9th times a. Since there's no exponent here, don't say it's 0. There is an exponent of a 1. A to the 9th plus the 1 makes a to the 10th. Let's do some examples where we have coefficients. These work is that you're going to do the same thing you did with the base and the exponents, but you're going to multiply the coefficients. Let's start out with number 20. Here I have a coefficient of 4 and a coefficient of 3. Multiplying them together makes 12. Then my base is still x, because the x is what's attached to the exponent. The base is not 4, the base is not 3, the base is x in this case. So then on the side, I'm going to show you that I'm going to take the base and add the two exponents together, 2 plus 5, to make 7. So your answer is 12x to the 7th power. Let's do number 22. Take your two coefficients, multiply them together. 5 times 6 makes 30. Then on the side, I'm going to take my base with the exponent, 2, and add it to the other exponent of 4 to make 30x to the 6th power. Let's do a more challenging one. Let's do number 25, right below it. Again, take your two coefficients, multiply them together to make negative 24. But here we have multiple variables with exponents. Just focus on the ones that have the same base. X to the 4th and x to the 4th, adding them together, makes x to the 8th. And then we can take, let me change my color, y squared. Let's do this color, y squared and another y squared, or y to the 9th, excuse me, to make y to the 11th power. So you just keep the bases separate and you add them separately. Let's do one where we have 3 different monomials. Let's do number 27. In this one, let's look to see where our coefficients are first. There is no coefficient here. That doesn't mean it's 0. That means there's an imaginary 1 in front. Here we have 6, and here we have an imaginary negative 1. I'm going to try to sneak in my negative 1 right here. 1 times 6 times negative 1 makes a negative 6 coefficient. Now let's talk about our a's, and then we'll do the b's after. Here we have an a to the 1 power, and then we have an a to the 5th power, and then we have another a to the 1st power. Adding them together makes a to the 7th power. Next, we can look at our b's. Here we have a b to the 1st power, another b to the 1st power, and another b to the 1st power. Adding those together makes a b to the 3rd power. And that is your final answer here. Box it up. Try to keep your letters in alphabetical order, your bases, your variables right here, in alphabetical order. It just looks a little nicer and more simpler form. What I want you guys to try is number 35 here. A little hint before you get started with number 35 is that I want you to use the product rule on what I'm outlining in purple. Get that answer. Then I want you to do the product rule for these in blue. Get that answer. Once you have both answers, they should be like terms. That means they have the same variables with the same exponents. Lastly, you can add them together to make your final solution. See what you get. Remember, I have a feeling some of you are going to get this wrong. Just on the side, let's say we had x to the 3rd y, or 3x to the 3rd y plus 2x to the 3rd y. Do not make this mistake. Do not say this is equal to 5x to the 6y squared. We do not change our base and exponents when we add and subtract. Only with the multiplication do we add the exponents. But in this step here, when we add, do not change these exponents. So in this example that I wrote on the side, it would stay as x to the third y. Big mistake that I have a feeling some of you will make. Try number 35 and have a great night.